Ever wondered how one thick, black liquid pulled from deep underground can power cars, fly airplanes, move cargo ships, heat homes, and even pave the roads beneath your feet? Crude oil looks like a single substance, but inside a refinery, it's transformed into multiple high-performance fuels using some of the most advanced chemical engineering systems on Earth. Today on Knowledge Hub, we're breaking down exactly how refineries turn crude oil into 6 different fuels, and the science that makes it possible. When crude oil first arrives at a refinery, it's far from clean. It contains water, dissolved salts, sulfur compounds, metals, and sediment. Before any separation begins, it goes through a desalting unit, where water is mixed with the crude, and high-voltage electric fields pull out salts and impurities. This prevents corrosion and protects sensitive catalysts used later in the process. Next comes the core of the refinery, fractional distillation. The crude is heated in a furnace to roughly 350 to 400 degrees Celsius and injected into a tall distillation column. Inside this tower, temperature gradually decreases from bottom to top. Hydrocarbon molecules separate based on boiling point. Heavier molecules condense lower in the column while lighter ones rise higher. This thermal separation divides crude oil into different fractions, each containing hydrocarbons of similar molecular size. At the very top of the column, the lightest hydrocarbons, mainly propane and butane, are collected and compressed into liquefied petroleum gas, or LPG, used for cooking and heating. Slightly heavier molecules condense higher up and form naphtha, which becomes gasoline. After further processing, raw gasoline isn't good enough for modern engines, so it enters catalytic reforming units, where platinum-based catalysts rearrange hydrocarbon structures to increase octane rating and improve combustion stability. In the middle section of the column, kerosene-range hydrocarbons condense. This fraction is refined into jet fuel. To meet aviation standards, it undergoes hydrodesulfurization, where hydrogen reacts with sulfur compounds under pressure, removing impurities and ensuring clean, efficient combustion in turbine engines. Slightly heavier fractions become diesel fuel. Diesel also passes through hydroprocessing units to reduce sulfur content and optimize cetane number, which controls ignition quality in compression engines. Further down the column, heavier hydrocarbons form fuel oils used in large marine engines and industrial furnaces. These fuels are dense and viscous, often requiring heating before combustion. International regulations now demand lower sulfur levels, so additional refining steps are applied to make them environmentally compliant. At the very bottom remains the heaviest residue, bitumen. This thick material is used in asphalt for roads and roofing materials. Even the heaviest part of crude oil finds a purpose. But distillation alone doesn't meet global demand patterns. There's usually more heavy oil than needed, and high demand for lighter fuels like gasoline and diesel. That's where conversion processes come in. In a fluid catalytic cracking unit, heavy hydrocarbons are exposed to high temperatures and fine powdered catalysts that break long molecular chains into shorter ones, dramatically increasing gasoline production. Hydrocracking performs a similar function. It uses hydrogen under extreme pressure, producing high-quality diesel and jet fuel, while simultaneously removing impurities. Finally, the refinery blends different streams together to meet strict specifications. Fuel isn't just separated, it's engineered. Parameters like vapor pressure, sulfur content, octane rating, energy density, and emission standards must be precisely controlled. Modern refineries rely on distributed control systems, real-time sensors, automated valves, and advanced process optimization software to safely manage high temperatures, high pressures, and flammable materials around the clock. So the next time you fuel your car, watch an airplane take off, see a cargo ship cross the ocean, or drive on a freshly paved highway, remember, it all began as a complex mixture of hydrocarbons underground. Through thermal separation, catalytic cracking, hydrogen treatment, and precise chemical engineering, that crude oil was transformed into 6 distinct fuels that power the modern world. If you have enjoyed this deep dive into the engineering behind oil refineries, make sure you subscribe to Knowledge Hub for more breakdowns of the systems that keep our planet running. And as always, stay curious.